can you guys look at this and go, oh, I see why this is a substitution type question? Yep, because if I let u equal this, then what I can do is say, well, I'm integrating u to the power of 4, aren't I? Yep, okay, I'll write that 4 properly. But if I write this as it is currently, I'm now trying to integrate u to the power of 4 with respect to x. Is that what I have to do? What do I have to do? Okay, so differentiate it with respect to u. Okay, so now what I've got to do is find that dx with respect to u. So du by dx is, sorry, that looks like a y. Du by dx is that 5? 5? Okay. Everyone happy with me so far?
No.
Now,
are we integrating?
I'm finding out my du dx parts at the moment. I will be shortly.
Okay.
I'm trying to find out when I differentiate u, I'm going to get an answer of 5, aren't I? Does that make sense? Okay. Now, if du and dx, if they were just, you know, like a constant, could you rearrange that formula to make dx the subject of the formula? Yeah, so in other words, dx equals a fifth of du. Can you see that?
Yeah.
Everyone see that? So what I do now is I substitute in this dx for this dx here. So I'm going to substitute in these dx's for each other. And now I'm going to have this fifth of du. So now I'm going to integrate u to the power of 4 with respect to a fifth of du. Why?
Because that's what dx equals.
Yeah, that's what dx equals. And when I used the chain rule before, the chain rule was I had to times it by the derivative, didn't I, of du by dx. So if you think about that, I'm actually undoing that part by doing it here. Okay. Some of it can be quite tricky. Now what I'm going to do is I'm going to put that at the front because that's a constant. So now I'm trying to differentiate u to the power of 4 with respect to u. What's that answer?
U to the power of 4.
U to the power of
5.
5, yep. Okay. But it's what I'm actually doing is it's a fifth of u to the power of 5 over 5 plus c. Okay. Which is actually the same as, no, it's a fifth. So this is u to the power of 5 over 25 plus c, eh? Do we need to make it a fifth of c?
Yeah.
Why? C is just some constant, eh? Doesn't even matter what it is. The fifth of c is still the same as whatever other constant it is. That's why it's c. I can make it k if I want to, just to change it a little bit. Change it up.
C
That's
could be
it.
anything, Tom.
I just did. Oh no, I didn't.
Can you rewrite it?
So,
It'll be the same in both cases.
I wrote it C.
Make C whatever. If it's a fifth
So,
of C and C's 5.
Is that my answer?
Just make it 1. Rather than 5.
Is that my answer?
Yeah.
Nah, you got to put the u.
Yeah, I do see.
Let's do it in terms of x's. So my answer is, what's that? 5x minus 7 to the power of 5 over 25 plus c. That looks like a funny 5. Okay. You happy with that? Okay, so when I do that differentiation, what's going to happen to the power of 5 there? It's going to be brought down the front. And it's going to be 5 25ths. Yeah? And then at the end of it, I'm going to multiply by the number in the bracket. Sorry, the derivative of the bracket, which is 5. 5 lots of 5 25ths is my 1, which is why it works, which is where the fifth du comes from. Does that make sense? The fifth du comes from the derivative of the bracket. When I'm doing the chain rule, that's the last part of the chain rule. Yeah? Happy with that? Alright, I'll pause this. So, example 2, which is actually question 1. So, what are we gonna let u equal? Why is it let u equal 2x plus 1?
That's inside.
Yeah, because it's the part that is inside the bracket, which makes our question just u to the power of 6.
Yep.
Okay? At the moment, we are integrating u to the power of 6 with respect to x. Do we want that? No. We have to integrate with regards to the same variable, don't we? Again, it looks like a y. Okay, so we need to make dx equals a half of du. So I'm going to change that for that part there, which means I'm integrating u to the power of 6 with respects to a half of du, which again I'm just going to put at the very front because it's a constant and make it a little bit easier for me later on. So I'm integrating that, which is a half of u to the power of 7 over 7 plus c, which gives me an answer of u to the power of 7 over 14 plus this k, or plus c, whatever you want to call it, which gives me my answer of 2x plus 1 to the power of 7 over 14 plus c. Okay? Everyone happy with that substitution method? Seem manageable? Okay. So on Wednesday we're gonna explore that a little bit more. Make sure we can get it right with the harder ones. We are going to utilise that in some of the chain rule, quotient rule, reverse chain, reverse quotient, log stuff. So understanding the substitution one there is important. What's the most important part about that? Yeah, the most important part is being able to go take that to that and then substituting it in for there, okay? So make sure you understand what I was doing there. If you don't understand it, speak up now.
I thought 8 was the first one that was different because I'm not like 7.